All right, here we have exponential and logarithmic forms of equations. And so we're going to start out working with putting things back and forth from exponential form into logarithmic form. Okay? Now, definition of logarithm. B and n have to be positive numbers. B is your base. Okay? And so let's look at n is what I call the answer. K is your exponent. Now I look at that basically in exponential form. And so looking right here at this expression or this equation right there, that's exponential form. Alright, so what I want you to know is that B here, okay, matches this little b down here in the log form, and b cannot be 1. Alright, now, so in this exponential form, b is going to be what I call the base. Okay, k K right here shows up in the exponential form. This is exponential form that's circled. The other one is called logarithmic form. So in exponential form, K is your exponent. And I want you to notice where it is in both forms. Okay? And then you have your n, which in your exponential form is your answer. Okay, so your n, whoops, we don't want to use blue because we've already had blue. Let's use green. Okay, so let's go back and find a green. So n right here is going to be your answer. Okay, now there's probably maybe more formal terms that you would use for that. But you see, what main thing I want you to notice is where they are in both equations. Okay, that's the important part. Where they are in these equations, and then we're going to take and go back and forth. Now I told you to remember a lot of these powers of 2, so we're using these powers of 2. Okay, 2 cubed is equal to 8. Okay, 2 to the 4th is 16. Okay, 2 to the 0, anything to the 0 power is 1. Alright, looking here, whoops, 2 to the negative 1 is 1/2. Okay, and 1/2 power is a square root, so 4 to the 1/2 power, the square root of 4 is 2. And then if we look at our basic exponential form, 2 to the k power is equal n. Some base, any base to the k power is going to equal n. That's from our basic exponential equation that's up at the top of the page. Okay, so let's go back. Let's go back here, try to move in and go and look at the logarithmic form. This is kind of a reverse. Let me get rid of some of these stray marks over here. Okay. Now remember, we're looking now at this form right here. Log base b. So see, b is your base in exponential form is down here in the log form. Okay. The answer, so let's locate these again. the answer we had in green, so that's here, that's the 8, and so that's there in exponential form. The base was in blue, so we'll switch over to blue. The base was this 2 in blue. It's kind of hard to highlight because it's a little small. And then the exponent was in green. It was in pink. Okay, so we go over here and pick up some pink. Okay, so that exponent there goes here as the answer. So what goes in that box will be a 3. Okay. So again, look where things are in one formula. Put them in the other one. So our base over here is 2. Base of 16 equals the exponent, which is 4. And a logarithm is basically an exponent. That's one thing I want you to understand. So what goes in here, in this second box here on log base 2, log base 2 of 16 equals 4. Again, see where they are in the problems that you've looked at. All right, now we're going to go back. Log base 2 of 1/2. So our base is, what is the base on the exponential form? Oh, okay, we're here. Log base 2 of 1 equals 0. Log base 2 of 1 equals 0. Now let's go to the one I was about to do. Log base 2 of 1/2 equals -1. Log base, this time my base on the next one is 4. Log base 4 of 2 equals 1/2. And on the last one, log base 2 of n equals k. And your answer, if you notice, the answer in logarithmic form is what was the exponent in exponential form. So let's go through and do a little more practice. Okay, write these equations in the other form. So the first two are in log form, so I need to put them in exponential. The second two are in exponential form, so I need to put them in logarithmic form. So we have our base is 3, so it's 3 to the 4th power. Remember, the power is the answer in the log form, equals 81. That's going from log form to exponential form. Okay, the base in the second problem is 4. 4 to the 1st power equals 4. So we've gone from log to exponential. Now in 3 and 4 we're going from exponential to logarithm form, and we use the word log to stand for logarithm. So we have log base 8 of 64 equals 2. Okay? The exponent is the answer in log form. The second one, number 4, you have log base 5 of 1 equals 0. Okay? So that finishes that first page of notes, kind of going back and forth from exponential form to, well, I thought I had, okay. So, let me now somehow I'm not finding, so let me All right, so here's another set of problems. It says evaluate the logarithms without the calculator. Now, many times what you want to do to evaluate a logarithm is to take it from log form into exponential form. And there's a couple ways you can do this, but that's one of them. So we have log base 5, and so think of it putting an x. Put an x here, okay? We have, remember, that's your exponent, base. So we have 5 to the x power equals 25. Now, if we match bases, so we have 5 to the x power equal 5 squared. If our base is matched, then we know our exponents must be equivalent. We've already done that. And so our answer then is 2. Okay. Looking at the next problem. Okay. Try to get a common base, but we're going to start putting an x there. So we have 4 to the x equals 64. 64 is the same as 4 cubed. So 4 to the x equals 4 cubed. So x is equal to 3. So my answer here will be 3. Okay. Now let's look at the next problem. Okay. We have 4 to the x power equals negative 16. Okay. Well, 16 is for squared, but it's not negative 16. And what you're going to find is that you can't take the log of a negative number. Now, sometimes the logarithm will be negative, but you can't take a log of a negative number. Okay. So that's a rule that you're going to, there's nothing we can raise the 4 to any power and get a negative 16. So this is going to be a not possible. We can't do that. Okay, log base 10. Now I'm going to set this, but we're going to go back and notice something. I'm going to set this. We have 10 to the x. So 10 to the x, set it up as exponential, equals 10 cubed. And so x equals 3. All right, now what I want you to notice here is that these bases match. And if you have that, then it makes it an easy problem because your answer is this exponent right here. Okay, so if your bases match, all you have to do is write down your exponent. That holds true every time. All right, let's go back and do a couple more. 3 to the x equals 1/3. 1/3 is 3 to the negative 1. So x must be negative 1. Okay. Now this one's a little trickier. 9 to the x equals 3. Well, the square root of 9 is equal to 3. Okay, so 9 to the 1/2 power okay, so here 9 to the 1/2 equals 3. And so the answer is 1/2. Okay. Now another way you could solve that might make more sense. Let's go this way. Let's do it this way. 9 is 3 squared to the x power equals 3 to the first. Okay, so that's 3 to the 2x equals 3 to the first. So 2x equals 1, so x equals 1/2. So that's a mathematical way to do that might make a little more sense than just recognizing that the square root of 9 was 3, and so that the exponent had to be 1/2. Okay. So let's look at this last problem. Similar type perhaps, but let's go ahead and just follow our rule of making common exponents. So I'm going to kind of draw a line here so that we're, working within this space. Okay, so we have 16 to the x equals 1/2. Well, we can make those. 16 is 2 to the 4th raised to the x power, and 1/2 is 2 to the -1. So 2 to the 4x equals 2 to the -1. So then we're going to go over here and set our, if I can make this quit erasing. Okay, so 4x must equal -1, so x is equal to -1/4. Okay, so like I said, the answer can be negative, but we cannot take the log of a negative number, and that's sort of sometimes hard to reconcile the difference, that's actually different, two different things. All right, that's the end of lesson 1. This lesson in logarithms, and so we'll get your worksheet out, and I want you to practice.